Okay, welcome back. We are on page 425, and we're going to do part 2 of our solving rational equations. Okay, so here's what we talked about last day, the steps that you can do. So using cross multiplication, by multiplying by the lowest common multiple, any other skills for solving linear and quadratics, and then just making sure that we pay attention to our non-permissible values. Okay, so in the previous lesson, okay, we solved this equation graphically. I'll just pull up the example. Here it is. Okay, so we did this graphically. We saw 0, 2, 0, 2, and we did it with the intersection or the x-intercept method. Okay, so now, of course, we're going to do it algebraically. So this isn't really any different. I see I've got those two terms. So my lowest common multiple, okay, is going to be the x plus 1 and x minus 1. I'm still going to pay attention to my non-permissible values, which is going to be plus or minus 1. Okay, and I'm still going to solve and then verify. Well, I don't need to verify because I already did that, but I guess I could verify if I really wanted to be super duper sure of it. Okay, so I'm going to multiply both sides by that. So then x plus 1 is going to cancel out. So, and I'm going to just show you this because I didn't last time, just in case anybody's confused on this. Okay, I'm multiplying through every term. I kind of did this too squishy on this side. 1 over x minus 1 equals 2, x plus 1, x minus 1. Okay, so whenever you've got an equation, anything you do to it, you've got to do equally to both sides, hence equation equal. Okay, and there's multiplying it through. Okay, so now I can cancel things out. Okay, and then I'm left with just numerators, no denominators. So then 3x minus 3 plus x plus 1, and then I've got the trinomial here. So this is difference of squares, x squared minus 1, and then multiplying that 2 in is going to give me 2x squared minus 2, right? Okay, so now I'm gonna put everything over, because I've got a trinomial, I'm going to put everything over to one side and set the other side equal to 0. So let's just get everything over to this side since my 2x is already here. Okay, so 3x plus x gives me 4x. Okay, and that's going to be negative 4x. Negative 3 plus 1 gives me negative 2. So when I add 2 to this side, that's actually going to disappear. Okay, so then this is my equation. So then I want to factor out that 2x. Oopsies, 2. There we go. Okay. And then I set each of them equal to 0. And there are my two answers. Oops, moving it down. There we go. Okay. So nothing new there. We're still using our those steps that we talked about last lesson. Okay. All right. So let's look at the next couple of examples. So consider this one here. Solve the following rational equation by cross multiplication. Okay, that's easy. This guy is going to get sent up there. So essentially I'm multiplying both sides by x plus 1, okay, which fortifies that whole idea that what I do to one side I have to do to the other side. Okay, and so then I distributed, right? That 2 times x plus 1 is 2x plus 2. Okay, then I can just get everything over to one side. X squared, so that's going to be minus 2x, that's negative 7x. Minus 2 is negative 8. Okay, and since I'm solving, that means I want x is equal to something. So I'm going to split my brackets and solve by inspection. What multiplies to be negative 8? That adds up to be negative 7. So that's going to be negative 8, positive 1. So x is equal to negative 1. and positive 8. Now, you might be thinking about the non-permissible value. Okay? X cannot equal -1. So we would reject it. So X is equal to 8. And you could verify by doing your intersection, left side, right side, algebraically, however you want. So explain why one of these solutions to the quadratic equation is formed in A does not satisfy. So essentially, this guy right here, if we were to plug in, if we plugged in X is equal to -1, okay, it would lead to division by 0. We would be dividing by 0. Which we can't do. Okay? Okay, so state non-permissible values, solve, verify. Okay, doing the same thing. So this one, I think the easiest would be to multiply through by that x. Okay, and then first off, that x means we can't divide by 0. Okay, so I'm going to multiply the whole thing by x. So x times x is x squared. X times 2 over x is just 2, and then x times 3 is 3x. So of course I'm going to move these all over. I've got my trinomial, and then I'm going to factor. So I think what multiplies to be 2, that adds up to be -3, well that's going to be -2 and -1. So x is equal to, oopsies, is equal to 1 and 2. And then you would want to verify left side and right side for both. Okay, so verify x is equal to 1, so left side, 1 plus 2 over 1, well that's equal to 3, which is equal to my right side. Verify x is equal to 2, left side, 2 plus 2 over 2. This is equal to 1. 2 plus 1 is 3, which is once again equal to my right side. So that's verified. Alright. So I stated my NPVs, I stated my solution, and then I verified. So my next example, same idea except for ding ding ding, difference of squares. Okay. So now, a couple ways you can do this. You could cross multiply, might be the easiest, because then those two are going to cancel out, right? If they're both on the same side, like that, they'd cancel out, because I'd multiply that up. Okay, and then I would multiply that up. So I'm going to have x is equal to 2x minus 4. Just want to make sure I did this okay. Yeah. Did it differently than they did in the book, but it's definitely quicker. Or is it wrong? Sorry, this is like the third one I did in a row, and I did not have a prep today, so I've done like 10 hours straight of math. Okay, so if I move that over, x is equal to 4, but then I'm missing one. What did I do? Just give me a second here. Difference of squares. Okay, so I'm going to continue on over here, and I'm not going to cancel these out yet. Okay, but I can state my non-permissible values. X can't equal plus or minus 2. Oh, I got it. Okay, I'm going to continue on here. Move this over. 0 is equal to x minus 4. Obviously, I'm going to solve for this. X is equal to 4. Okay? So that's the way I would have just done it naturally. If you didn't cancel these out, okay, you would have gotten, so those would have gotten multiplied up there. So you would have had the 2, which remember, difference of squares here, okay? And then that's going to get written up there, x plus 2. So then if you expand that out, so x squared plus 2x 2x squared minus 8. Move everything over. Okay, so that's going to be x squared minus 2x minus 8. Go ahead and factor x, what multiplies to be 8, that adds to be negative 2 is going to be 4 and 2, and then we get negative plus. That gives me x is equal to 4. That gives me x is equal to negative 2. Now, x can't equal negative 2. That's extraneous. Okay? So as you could have done it this way, which is the way the book shows, but I would just do it this way. It's still mathematically sound. You just don't get the extraneous root, which is extraneous anyway. Okay? And then you would verify. So you could verify left side, right side in your graphing calculator, or you could just plug it in. So left side is going to be equal to 4 over 4 squared minus 4. 16 minus 4, so that's going to be 4 over 12, which is going to be 1/3. Right side is going to be 2 over 4 plus 2, which is 2 over 6, which is also 1/3. Yay, math. Okay. All right. One more example. So an equation with no solution. So show that the equation has no solution. Alrighty. So first off, non-permissible value, x can't equal 3. Oops. Okay, and then the next thing I would do is I would multiply through by that lowest common denominator. So I would multiply by x minus 3 to get rid of those. So it's going to get rid of those two, and it's going to put an x minus 3 on that one. So x plus 10 minus 4 times the x minus 3 is equal to 10x plus 4. Okay, and then you just have to multiply out, so, or distribute rather. So that's going to be 8x plus 10 minus 4x, and then negative 4 times negative 3 is positive 12. And then I just need to gather all my like terms. So once I gather all my like terms, okay, I get 18 is equal to 6x. And then x is equal to 3. Wait a tick. Okay, we would have to reject x is equal to 3 because it's a non-permissible value. Therefore, no solution. Dunsies. Okay. So, I think like one of the best kind of secrets is doing that, just multiplying through by that lowest common denominator, because it just gets rid of it. There's other ways you could go about doing it, but that's the easiest way, I think anyway. If you find a way you like better, go hard, as long as it's mathematically sound. Okay, lesson over. See you later.